Welcome to AP Podcast 17.4a. Today we're going to talk about cell potential and concentration. And you guys know concentration means molarity. So what we're going to do is we're going to find out that if you change the concentration in these galvanic cells that we've been dealing with, it actually will change the voltage. And we're going to eventually get to the point where we can use an equation to figure out what that voltage change is. But first we just want to think back to LeChâtelier and look at what would happen if we change the concentration of a cell with the following reactants. So look right here. You've got some aluminum solid and some aqueous aluminum, and we're going to run this reaction. Now, what would happen to the cell if we had the concentrations like this? So we would have, this would be 2 molar here, right? And this would be 1 molar there. Now, you got to remember one thing. When we're talking about the voltage, remember that little 0 there? That means under standard conditions. And those standard conditions is 1 molar, 25 degrees Celsius. Okay? So we're talking about a cell that is not standard. All right? So in this case, we've got a cell where this is 1 molar and this is 2 molar. Now, according to LeChâtelier's principle, which way would this reaction shift? Hopefully you would go like this. Well, it's going to shift this way because we've got more stuff there than we have there. So if we're shifting this way, and we think of electrons being produced that way, what would happen to the cell? Well, the idea is that under these conditions, it would be less than what you would get at standard conditions. Hopefully that makes sense. So now let's look at another condition. In this condition, let's see, in the second one, what do we have? We've got a 1 molar condition of aluminum. They're standard, right? And then over here we've got a 3 molar. Now, what would that cause to happen? Well, the shift, according to LeChâtelier, would go that way, and therefore we would produce more electrons. So that would be greater than what we would get under standard conditions. Make sense? I hope so. And then what will we have happen here? Concentrations were the same. Well, under those situations, we're not going to get any benefit either way, right? Because it's not going to cause a shift forward or in reverse because the concentrations are the same. So the voltage at standard would equal the voltage that we have right there. All right? Hopefully that makes sense. Now let's talk about what would happen if we had a different type of cell. Imagine I have something like some silver floating around here. Right, and I've got some silver floating around here. Okay, and I've got a 1.0 molar and a 0.1 molar. Okay, now same stuff floating around, but it turns out because the concentration is different, we'll get a driving force. So the electrons are going to flow this way for reasons I'll show you with a real diagram in a second, just not a Richardson drawing. And what's the reason they're going to flow that way is you are going to, if you look at this bullet right here, they're going to flow in the direction that will equalize the ion concentration. So somehow this has got to decrease, right? And this has got to increase. And will it go till you get 0.5 and 0.5? Who knows? I guess if you run it long enough, maybe it would. But there's probably other factors involved. And then the important thing is that this voltage that we're going to get here is typically going to be small. So it's not like something you can gain a whole volt or two just by having different concentrations. But you can get a difference, right? So let's look at a real drawing. Not a real drawing. Alright, so here's a real diagram, and let's look at exactly how these concentrations differ a little bit. So I've got this silver bar, and I've got this silver bar right here. And remember, this concentration has got to increase, right? And this concentration's got to decrease. So how is that working? Well, if you look at this picture, you can see right here, the silver bar is getting smaller, right? So what's happening is silver is going from solid, right, to the aqueous, right? So we've got a solid there, and we've got an aqueous, right? Okay, so we've got that happening. And then over here, the silver that's floating around, right, is gaining an electron and going to solid silver. So by doing that, the concentration of the silver is decreasing and the concentration of that silver is increasing. And that little change there will cause these electrons to flow that way. And the only reason that this silver is plating on here is because electrons are flowing. That's attracting the positive silver and plating on there. Okay, and this would run until this silver bar was gone. And or I mean, obviously there's other situations there, and so the concentrations are going to get closer and closer to each other. All right, so let's practice one of these. Here's another diagram, and if you want to pause it and figure it out, great. If not, you can just listen to me talk here. But what we want to do is we want to predict the direction of the electron flow and designate the anode and the cathode. All right, so the first thing I want to look at is what are my concentrations. I got 0.01 molar and 0.1 molar. Okay, you may have noticed that the electron flows towards the greater concentration, right? And hopefully that makes sense. Again, what's got to happen? This has got to decrease because you can't increase the iron. I mean, we could increase iron here and decrease it there, and oh wait, that's what we're going to be doing. Sorry, we're going to increase the iron here and decrease it here, right? So iron's going to plate onto there, decreasing that, and iron is going to come from the bar into solution there. Right? So where's the reduction happening? Well, we're going from iron 2 plus to just iron solid, right? So that's reducing. So here's reduction, and so this must be the cathode. Okay? And so this would be the anode. All right? All right, so that's the first part. Now let's see what the next one is. If the concentration of the right compartment is changed from 0.1 to a very, very small amount, what would change? Well, I think it's obvious to you. If this amount were 1.0 times 10 to the negative 7th molar, now this is the big concentration, right? So electrons would be flowing that way. And we would be switching, of course, the cathode and the anode. And so there you have it. All right? So that's what happens when you have concentration differences. You do get a voltage. It's a small voltage, and it's good for us to be able to predict which way it's going to go, whether it's going to be to the left side or the right side. And we'll talk about this a little more in class, and if you have any questions, I'll see you then. See you later.